So, today we're going to unpack something really cool, a powerful toolkit for innovation that sits right at that fascinating intersection between engineering and, all that dense intellectual property law. It's really a whole different way of thinking about how we create things.
Yeah, I know. Why invent when you can circumvent? That sounds a little sneaky, right? But hang on, this isn't about copying. It's actually about a much smarter, more strategic way to innovate. It's about looking at existing patents not as these giant brick walls, but more like puzzles, just waiting to be solved. And there's an actual name for this whole approach. It's called Design for Patentability, or DFP for short. It's a pretty sophisticated method for creating totally new, patentable solutions, sometimes by really cleverly navigating around what already exists to build something that's fundamentally new and a lot of times even better. All right, first up in our toolkit, we're going to learn how to deal with a really tough kind of patent. The experts have a great name for them: dragon patents. So, what is a dragon patent? Well, the metaphor is perfect. Imagine you're fighting one of those mythical hydras. You cut off one head, and two more grow back in its place. That's exactly what these patents are like. They use such broad, generic language that when you try to design around one part, another part of your design ends up taking its place, and the dragon just regrows. It feels totally impossible to beat. Let's make this real with a classic story. Hyundai wanted to develop a new airbag system to protect passengers in the backseat. Great idea, right? The problem was Honda already had a patent for one that used a means of support. I mean, think about that phrase. It's so vague. Anything Honda tried to add to support their airbag would technically fall under Honda's claim. They were completely boxed in. So, what do you do? Seriously, think about it for a second. How do you get rid of a means of support when the very act of replacing it just, well, it creates another means of support? It's a real head scratcher. And here's the genius move. Hyundai's engineers didn't add anything new. Instead, they just looked at what was already in the car. They saw the headrests, so they completely redesigned the shape of the airbag itself, so that when it inflates, it wedges perfectly between the existing headrests for support. See, they didn't add a means of support, they just cleverly used one that was already part of the car. And just like that, the dragon was slain. Okay, that was awesome. Now, let's get even more clever. We're going from slaying dragons to finding ghosts, or what are called ghost components. A ghost component is something that a patent absolutely needs to work, but it's never actually mentioned by name. It's just implied by the language. For instance, if a patent talks about two hydraulically isolated chambers, well, you can't have that without some kind of wall in between, right? The patent doesn't say wall, but the wall is there. It's a ghost. And if you can spot these ghosts, you can unlock entirely new ways to design something. Here's another case. There was a Philip Morris patent for an e-cigarette that described having multiple independently controllable heating regions. Okay, stop right there. Independently controllable. How do you do that? You need a controller, some kind of chip or circuit. But the word controller was nowhere in the patent. That was the ghost component. So the challenge became, could you design an e-cigarette that didn't need that ghost? So what they did was so cool. They dug up this old 19th century technology called the electric candle. They designed a single heating element where a hot spot just moves along automatically, kind of like a fuse burning from one end to the other. It became self-regulating. And because of that, there was no need for multiple regions, and more importantly, no need for that ghost controller. They literally designed the ghost right out of the system. Just brilliant. So you see, getting around patents isn't just about removing stuff. It's also about what you create. To get your own patent, your idea can't just be some obvious combination of things. It has to have what the law calls an inventive step. Here's a really simple way to think about it. If you just glue a pair of wings onto a laptop, well, that's not really inventive, is it? It's just a laptop plus wings. Kind of predictable. But what if those wings were also designed to help cool the computer's processor? Whoa, now that's a synergistic result. The combination creates a new, totally unexpected function. And that's exactly what we saw before. Hyundai didn't just move a support, they changed the airbag shape to create a whole new support system. The e-cig team didn't just remove a controller, they created a self-regulating system. That synergy, that's the inventive step. Okay, so we've been talking a lot about offense, how to get around other people's patents. But now we're going to flip the script, because the real reason to learn all this stuff is for defense. It's so you can build your own patents to be so strong they're basically unhackable. And that requires a huge mindset shift. You have to put on the hat of your biggest competitor. You have to look at your own amazing invention and ask, okay, how would I try to break this? How would I get around it? You have to hunt for your own dragon words and your own ghost components. You've got to find the weaknesses in your own creation before anybody else does.
And you have to realize that not all patents are built the same. If your patent is mostly a list of physical parts, what they call component-based, you've got to make sure no single part can be easily removed and have its job done by something else. But if your patent is based on an attribute, like its location or a sequence in time, you have to be damn sure that attribute is absolutely essential and can't just be contradicted with a clever redesign.
I absolutely love how the source material puts it. You basically make your patent circumvent opposite. You're taking the very tools of a hacker and using them to build a fortress. You make it unhackable. So why does all this matter? Well, here's the kicker. A truly unhackable patent often results in a better, more elegant, and even lower-cost product. When you stress test your own ideas this way, you usually simplify them down to their core genius. And that protects you from competitors, it boosts your licensing revenue, and it solidifies your place as a true innovator. It's a win all the way around. So I'll leave you with this question. We've just spent all of this time learning how to strategically take a patent apart, piece by piece. The real challenge, and the biggest reward, is to apply that same thinking to your own work. Now that you know how to do it, how will you build the next idea that can't be broken?